Hi, good evening, everyone. I am Vinod Venugopal, currently serving as Chapter President-elect and one of the Chapter Board of Directors. On behalf of ASHRAE Bahrain Chapter and BOG, I would like to welcome all our chapter members and all other participants to today's webinar, ASHRAE Standard 189.1 and the International Green Construction Code by Dr. Thomas Lawrence. This webinar is sponsored by Train, one of the leading manufacturers of air conditioning units, and Bahrain Trading Agency, licensed distributor of Train air conditioning system in Kingdom of Bahrain. Dr. Thomas Lawrence was named an ASHRAE Fellow in 2017 and served as a Director at Large on the Board of Directors for ASHRAE from 2016 to 2019. He is a past chair of ASHRAE Technical Committee 2.8 and a member of the committee that wrote and maintained ASHRAE Standard 189.1 for high performance green building. I welcome Dr. Thomas Lawrence with a special greeting. Let me now invite Mr. Shabazz, our Chapter Technical Transfer Committee Chair, to speak briefly about ASHRAE and the chapter. Over to you, Mr. Shabazz.
Thank you, Vinod. Can we have the presentation slide shared, please?
Yes, 1 minute.
It take a minute. You have to make me presenter and then. Oh, that one. Oh, sorry.
Good evening, everyone. My name is Shabazz Salim. I am serving as the CTTC chair for ASHRAE Bahrain chapter. I will be reading out the ASHRAE Code of Ethics for you. Yeah, next page,
I'm sorry, some technical issues.
ASHRAE Code of Ethics. In this and all other ASHRAE meetings, we will act with honesty, fairness, courtesy, competence, inclusiveness, and respect for others, which exemplify our core values of excellence, commitment, integrity, collaboration, volunteerism, and diversity, and we shall avoid all real or perceived conflicts of interest. ASHRAE Research and Promotion Campaign. Research and Promotion Committee manages RP campaign, which raises the fund at society level and also at chapter level. Traditionally, RP campaign was expanded 10 years ago to include support for education and ALI endowed research through ASHRAE Foundation, Young Engineers ASHRAE programs, and ASHRAE scholarships. Research, the backbone of ASHRAE, remains the primary fund of the program with over $2 million raised annually for this program. We encourage non-members to please join ASHRAE. They can log into the website address given on the screen or contact the details given on the screen. We would like to welcome our new members to the ASHRAE Bahrain chapter, Mr. Jamal Muhammad Nazir Ahmad, Mr. Michael Azair, and Mr. Sugesh K. Bhaskaran. ASHRAE Global Training Center conducts online training web series. The upcoming courses are given on the screen. You can log into www.ashrae.org for more details. ASHRAE also offers ASHRAE certification programs, which are shown on the screen. You can log into ASHRAE website for more details. ASHRAE's this year's presidential theme is Personal Growth, Global Impact, Feed the Roots. The theme explores ASHRAE's expansive root system from the society's founding through its extraordinary global growth and impact to the built environment. 3 sets of roots were established to help members grow: member-to-member connections, grassroots chapters, regions, and technology. Today's event is ASHRAE Standard 189.1 and the International Green Construction Code. I once again welcome Dr. Thomas M. Lawrence to speak on today's event. Please note, this presentation has been pre-approved for 1 hour continuing education credits by GBCE and AIA. You may please post your question in the question panel or using the question button on the mobile. Please fill the evaluation form at the end of the webinar. Thank you. I now call upon Dr. Thomas Lawrence to present the webinar. Thank you.
All right, I got it pulled up. Hopefully everyone can see that. And let's see if this works when I start the slideshow. Doesn't look like it's doing that. So let me think there's a way to, might have to just do it slide by slide like this. Just a matter of time. Is that large enough for everybody to see? There we go. Sorry, the slideshow wasn't going to work. So anyway, good afternoon, good morning, good evening, whatever it would be for everybody. It's morning for me, but I'd like to welcome you to participating in this. The topic I'm talking about here today is ASHRAE Standard 189.1 in the International Green Construction Code. As was mentioned in the introduction, I've been involved with the 189.1 standard since day one, since the day we started planning for doing this, and that was, I think, 2006 or so. And it's the purpose of the creating that is, ASHRAE was looking for, taking the leadership in many ways of setting not just green building rating systems, but something be written more in a code type language. And so I put together this presentation. I've been doing this. I've probably done this close to 100 times over the years. And as the standards evolved, it always has to be updating and going where from. A little bit of a reminder again, ASHRAE membership, ASHRAE is truly a global society. And what we have, we have a lot to offer in terms of providing information and resources for the members, looking for volunteers in the local chapters. This is a great way, especially for younger members, to kind of get involved with that ASHRAE, to learn about what's going on, build your resume, and also just basically increase our networking. So, as was mentioned, we have probably not too many that are AI registered architects, but, perhaps, some people may want to have this as for the continuing education credits for the, the U.S. Green Building Council and LEED and other aspects of that. And there is the course ID number that you can, go through and copy that down. I will be sharing this presentation right after the talk, so you can post that on the website so you have access to that if you need. So looking at, what is our objectives? What do we want to try to get out of this here for today? Well, I want to really talk about some of how the evolution is going on in high performance green buildings. Differentiate that between the standard and the codes from other certification systems, LEED, Green Globes, there's a lot of them ones that are all around the world. Talk about the key requirements that are included there, and they're common across all of these particular programs. And they talk about how basically demonstrate compliance with the codes. One of the things that in my, I'm actually in the faculty in the University of Georgia now, but I also spent 18 years in industry, about half and half in each now in terms of the time. This gives me an opportunity now to go participate as a distinguished lecturer and other type of events, literally all around the world. You kind of see from here. 33 different countries, and 3 of them virtual. I mean, adding in, oops. Right now, we have Bahrain is added to that point. You kind of see the little blue star from there. So talk a little bit about, the history of the standard. Many of you probably have heard of the ASHRAE standard 189.1. The work started on that in 2006, but the intent to develop something that could be adopted into building codes, something that's written in a legally enforceable language. The International Green Construction Code was started in parallel by the International Code Council. They didn't know if ASHRAE was going to actually come up and actually make this happen or not. So you had 2 programs being developed in parallel for a while. ASHRAE Standard 189.1 was first issued in January 2010. IGCC was released in 2012. They continued on, basically in parallel for a while. But in 2014, the International Code Council and ASHRAE reached an agreement, basically how to package the 2 of those together, how to market it, and how this goes about. So in the US and Canada, ASHRAE will market the International Green Construction Code. Outside the US and Canada, ASHRAE still publishes and sells the ASHRAE Standard 189.1. But the key part of this right here is down at the bottom. The Standard 189.1 is the technical basis of the International Green Construction Code. The agreement between ASHRAE and the International Code Council is ASHRAE is the technical organization. We know what we're doing technically. The Code Council, or how to put that and package that into something that could be legally enforceable in terms of a building code. So it's actually a good marriage in the sense of 2 organizations focusing on what they do best and creating a product that works out well. There are some administrative portions, comments on that would be, one of the difference between the International Green Construction Code or the ASHRAE Standard 189.1 is that, those are written, intended for being mandatory code type language. Programs like LEED, depends on the US or India or any place like there, they are really more still voluntary. A building project team can choose to go for LEED certification or not. But if it's written in the code, it's set up so at least a jurisdiction could adopt that and say, this is what you have to do. Everybody has to do this. So that's really the big distinguishing difference then. So the purpose of creating any of these really, a code or a standard or a grading system is to have some ways of making so that a high perform, a green building, and actually the term used to be green buildings. 20, 25 years ago, we talked about just green buildings. Really, we've added in the term high performance buildings now. In fact, the high performance building is probably my preferred term for what we're talking about, in terms of these better performing buildings. But it also does more than just small parts of the building operation. You're looking at the whole impact of the building on the local site, the materials used, the occupant comforts and health, because that's why we build buildings for people, right? And so that's why we want to have that. They should be comfortable there. Conserving water resources, energy efficiency, and just an overall enhancing resilience of our systems. Now, what the International Green Construction Code applies really only to new buildings and their systems, or maybe a new portion of buildings. Let's say if you were going to change out the lighting system or change out the HVAC system in an older building, well, then it would apply to that. It does not apply to smaller single-family dwellings, 3 stories or less at that point, because those are different parts of the code process, at least in the United States, in terms of where they apply. So because it's written as a code, we have to look for how do you demonstrate compliance with this? Because that's, in theory, that's what you're doing. Some aspects in each of these topic areas, energy or water or something like that, were considered so important by the committee that they're made mandatory, like everybody has to do this. But then other items are still important, but we look for 2 different ways of proving compliance. One would be what we call prescriptive compliance path. So for a prescription, you get a prescription for a certain drug and you take to the pharmacy and you get that filled. So it's a specific, you have exactly this. Performance path is some way that the team could demonstrate that the performance would be at least as good as what the prescriptive had they done that. And what the reason for that is that gives the project design team options. If they have what they think is a better idea to achieve the same result, let them do that, you know, and just document and work from there. And that's really good way of going forward. Now, I'm sure you're probably aware that, you know, ASHRAE produces a number of standards that are around, and there are certain key ones that already were developed or in parallel with the standard 189.1 that've been around for a long time. And if you look at, you know, design of a high performance green building, it includes everything, you know, air quality, energy, water, thermal comfort, et cetera, et cetera. And so instead of rewriting all those criteria that might be contained in, say, the energy standard 90.1, you know, it just adopted. You know, the 189 standard will say, you comply with standard 90.1, except here. Here's how we modify it. And then the modifications make it even more stringent, you know, because the standard 90.1 is a minimum level we're talking about here for a high performance, so it should be beyond that point. And so that really, if you look at the paper publication of this standard, even if it covers everything within a building, it's not that thick. You know, there's only maybe a couple hundred pages at most that covers all that point. If we included all that material, it would be 2 or 3 times that, and that's just not what we wanted to really come about. So the overall organization of the standard, what it covers, you know, basic, you know, first few chapters are just introduction or administrative part of that, but it covers, you know, things, sites, the water, energy, indoor environmental quality, materials. And then one thing that really was new, particularly when the standard was created, is not just talking about the construction, how you build a building, but also planning for the operation of the building. You know, if you can design and build the greatest building in the world, but if you don't operate it well, if you don't maintain it, you're not going through and then just, you know, operating as was intended, it's not going to be as good. It's not going to be high performing. One important thing to note right here, then as we go through and talk about a little later on in this talk, you know, there are certain specific criteria, but we set out really to specify what the performance should be like or specific equipment requirements, but we don't say exactly how that's implemented. And the main point of that was not to give some artificial monopoly to one particular manufacturer or another because they can, you know, create this piece of equipment that can perform this way that's specified in the standard. So it gives the options of going through. Also, what has been looked at and created in the last several years are what we call jurisdictional options. Again, the standard 189.1, the International Green Construction Code, is created such that a local jurisdiction, you know, Bahrain, you know, my city, Athens, Georgia, Atlanta, wherever, could adopt this as part of their building codes, but gives them with suggestions, say, you know, if you don't really want to do this one part of it, that's okay. That's your choice. So the idea is right there, makes it easier for other cities or other localities to adopt that as part of their standards. So I'm going to jump right in now and talk about you know, some of the technical details of this. I'm not going to spend a whole lot of time on the sites part of it. That's not really an ASHRAE thing, although there are some of us that are involved in some aspects of this. Everything in there in the site section is now mandatory, and so you have to do. It talks about, you know, where you should be allowed to build building projects, do an assessment of the site, you know, but also some of the key topical areas, you know, the urban heat island. Most people probably have heard of that term, you know, the idea of, you know, urban areas being warmer than surrounding rural areas. The idea of light pollution and stormwater management and how you integrate that building within, say, the transportation system in the locality. It's also kind of talked about some newer things, you know, electric vehicle charging stations and some minimal requirements for there, for at least beginning to plan for that, because as we see, you know, worldwide, you know, that is somewhat the foreseen trend in terms of what would be more electrical, you know, maybe a fully electric or, you know, kind of what I have, a plug-in hybrid. So I get a little bit of time with electric and then it goes into a regular hybrid vehicle. Now let's spend the topic on water efficiency. You know, that's something that probably is very important to you, but it's actually really becoming important everywhere around the world. And so the way you look at, some of the mandatory part of it, just within the building systems, having very efficient plumbing fixtures. And there are set criteria. The U.S. EPA, Environmental Protection Agencies, created a program that they call Water Sense. And it just listed specific criteria in terms of minimum level performance, maximum amount of water use per, say flow per minute, or amount of water used per cycle for a water cleansing system, washer, dishwasher, or something like that. And there's specific limits on that. So if you comply with this in the US, you can actually get the little sticker that on the fixture that says you prove you comply, but also lists in here what the flow rate should be. Within HVAC systems, we have set criteria for things like with cooling towers, maximum amount of water, that's consumed, eliminating, efficient drift eliminators. And, down the bottom right here, the idea that maybe not quite as important to you, although certain times of the year, my understanding of the region, and I've been, to your region several times, but there are certain times of the year where you can actually collect some condensate, even in a hot, drier type climate. Where I live at, we're a warm, humid, or hot to warm, humid there. We get a lot of condensate collected up there. That's a great source of extra makeup water we use. We do that a lot on our own, on my university campus. We collect condensate and use it for makeup water and cooling towers. Now, speaking of cooling towers, though, if you made operations, what they call, cycles of efficiency, or cycles of concentration, basically it's how efficient we are at using that water. Depends on what the makeup water is in terms of the hardness of that. And I know, I'm not sure about Bahrain, but I know in say UAE and other places right there, there's huge amounts of, the chilled water distribution networks, and they use cooling towers as their source of, the heat sink. So, this is an important time to look at that point. So this is a way just being more efficient, and it's possible to do these. These are not really stretch, high criteria. It's just, being safe and sane about going about this. One other thing that's included in there, and this is related to, three main topics within the standard. And within the standard, in the listing of equipment, it specifies you have, basic monitoring devices, measurement devices, sensors that will record how much, in this case, water is being consumed, and then also sends that information to a central storage system within the building, so you record it. So you basically have mapping out over time of what's being done. And just picking one quick example right here, for a cooling tower, if you have the total flow through the cooling tower of greater than 30 liters per second, which is not that big, at least you have a makeup signal on there. You're recording how much of makeup water is being used. And then, so now you know at that point. And then what that's going to do is, perhaps if you look, if there's something goes wrong, a valve fails, and you start using more water, well, that recording signal could detect that and at least send you a note that, hey, something happened here. All right, let's move on to the energy, the kind of the core part of the whole standard. Just very briefly, and this is actually related to the U.S. in terms of the energy consumption, the thousands of BTUs per square foot per year, or megajoules per square meter per year. And all I want to do in talking about this right here is that over the last 20 years, the standards that have been created by ASHRAE in particular have developed and really decreased the amount of energy consumption potentially within, say, new buildings that are being built to that standard. Roughly a 40 or actually 50% or more reduction compared to what we had in the prior standards in, say, 1999. That's a good thing, and that should give us incentive to look at and adapt, those higher efficiency standards to any building that's being built. So within energy, there are, some general compliance paths. How we doing? You see on the left-hand side, there's a list of several items that are mandatory, meaning everybody has to do this. Then there are the prescriptive options that cover, HVAC and lighting, as you can see from that. Or an alternate would be the performance option, going about this, and from the energy cost. And also kind of note right here, it says the CO2 equivalent, basically computing the CO2 emissions from the building and comparing that, using that as another evaluation criteria. So going into the mandatory, the idea of renewable energy systems or making them renewable ready, really formally up until 2020, the standard 189.1, their National Grid Construction Code, only required that you have a building be what we call renewable ready. You could install at some time in the future on-site renewable energy. You have the space allocated on a roof, you have maybe, wiring chases so you could actually tie it in fairly easily. But starting a couple years ago, the standard was modified that basically says, all right, you install just a minimum amount of solar PV systems on the building, and that per 22 watts per square meter. That per square meter is basically the total roof area over the conditioned space of the building. And it does give an option that you can meet this with what we call purchase renewable energy credits. I'm not sure if those are available in Bahrain, but in the US you have the ability to basically purchase renewable energy from some other source. So you're subsidizing, maybe a wind farm or a solar farm someplace else, because you're not putting it on your particular building. Other things that are part of mandatory, energy consumption management, looking at this, measuring, similar to what we had in the water, collecting energy consumption for each supply source and also where they're going, the different places where you're using it on a gross lumped scale. Those meters communicate back to a central recording system, and you store the data, for a minimum of 3 years. So you've got hourly, daily, monthly, annual energy consumption. You can go through and analyze that and get that information about from there. Now, again, what the purpose of this? It tells you where your energy is going. So looking at in the lower left-hand side right here, again, these are all lumped together. So it's not requiring energy measurement of specific pieces of equipment. I've been trying to push for that for a number of years, but we just can't quite get that worked out there. So in HVAC, if you got the total connected electrical load of 100 kVA, which is not that large, or lighting systems greater than 50 kVA, again, not that large, and plug loads. So you're basically taking measurements of those 4 main systems. As a minimum, it's only 4 pieces of data you're collecting, but at least you know where the energy is going. And it might give you some information on, say, the lighting system. Maybe your lighting control system is not shutting off lights in a certain part of the building, at night, when late in the morning when people are not there. That measurement will tell you. You'll be able to see that from your data and it worked from that point. Also, the terms, audit. This is actually a newer term or portion that was added into the standard, about 4 or 5 years ago now. Looking at what we call automated demand response. Demand response is adjusting, the energy, particular electrical energy consumption within a building due to maybe the strain on the electrical grid. It's a time when everybody's using a lot. The electrical grid has to keep up with that point. There are ways of looking at, buildings can sense that, maybe get a signal from the utility says, please reduce your load by, 5 or 10% or whatever, what they were asking for. So what we're saying in here in the standards is the buildings should have that capability to automatically control the equipment loads to lower the peak demand. And some of the suggestions or some of the things are set, like HVAC set points. You may temporarily adjust by a minimum of 1.7 degrees C, the temperature setting for during the cooling we're at that point. A lot of studies show that if you do this, and maybe if it's done on a gradual stepwise basis, people don't notice. That's really a fairly small change in the overall temperature setting. Other parts to look at, if you have a piece of equipment that has a variable speed drive on it, variable speed control, maybe set the maximum to 90% of that, design speed. So, a fan is operating, but it's not allowed to operate at 100%, maybe only 90%, and the power consumption, say for a fan, when it's to the basically the speed of the fan cubed, so 0.9 cubed, being like more like in the 70% range in terms of what the total energy consumption. So that's a significant reduction without really reducing too much of the overall capacity. And then also some things to look at in terms of lighting, actually dimming back or cutting back some on the lighting levels. Again, all these are in the setup for a situation when there is a need for doing demand response on the grid. That's not saying you do this all the time. It's just only when the electric utility says you might want to go through and do it. Another new thing that's been come forward is actually fault detection and diagnostics. And this is fairly new. And that the capability of doing this has really only come around in the last maybe 20 years or so. The monitoring, your monitoring of the operation of a piece of equipment. And, there are ways of doing so. And in fact, when I was doing my PhD, I was working for a professor. He had some other projects that they were monitoring, rooftop units or something like that, that actually could determine when a failure might occur based upon key pieces of information and be able to predict it and sense the degradation in performance. So these are permanently installed devices that monitor the operation. They do it as a minimum once per hour, take a sample. That has the capability to analyze that. And it's kind of almost like artificial intelligence in some ways of tracking what's going on and be able to tell the operations team, hey, I think I might be going to fail sometime here soon. And this is what it is. Maybe the compressor is going to fail or something like that. That is a way of helping us improve the overall performance and actually increases energy efficiency because you're not operating sometimes when it's not quite as high of efficiency as it could be. So those are the mandatory items going there. Prescriptive parts of these. So these are the list of items that should be chosen, you have to do. And then remember, there's a performance option as an alternate to all that. So we're going to go through and spend some time just what include on the prescriptive part of that. So remember, we had within the the mandatory portion of this was having baseline energy, the ability to install some of that. Now we have, it actually says, two different approaches. One, you go in and install it anyway, put that on your roof area. An alternate approach is have you comply with what we call Energy Star, basically within the United States, strict energy efficiency requirements. There's a whole appendix B of the standard that sets the efficiency for a pump or for a chiller or things like that. Now it allows you to go ahead to produce these or purchase these green power or renewable energy credits, based upon the size of the building. That gives you the approach that basically opt out, but again, you're still supporting renewable energy projects someplace else. So this alternate approach, looking on here, the standard approach that is set based upon the type of building. Now, the difference between the total roof area and the mandatory part. Now we're getting into the prescriptive option part. It says you have an office building, 44 kilowatt hours per square meter per year at the point. And this again, looking at the overall total area of the building, working from there. And if you're going to produce or purchase renewable energy credits, they're actually adjusted if it's through like a community solar project or something like that. Now look at HVAC. All right, now we're talking really ASHRAE stuff, right? So the general concept, just as a reminder, is that everything from standard 90.1, the International Green Construction Code, or standard 189.1 from ASHRAE, says you adopt that with modifications. And so really we're going to talk about the modifications. So looking at, one of the aspects of this, densely occupied spaces, ventilation for that, some people call it demand control ventilation. And so there are just requirements to go through and include this as part of doing there. Whoops, I want to make that a little bit bigger so everybody can see that. In terms of there are some exceptions that are put in this. And in the little red note down at the bottom, the type of demand control ventilation control was not specified. And when I say that, by that, most commonly people will use CO2 levels in the room or in the zone to determine how much ventilation per person we're actually getting. But there are other options that are becoming available. sensors that actually are becoming more. They can actually count the number of people by infrared, how many people were in the space with a fairly good accuracy. That type of capability was not really around 20 years ago when we began, working on standards like this. But so we're getting more capability, and this is a key point where, we're not specifying how you do it exactly. It just says you have some capability of doing the control. That's a good example of that. Leakage testing. So testing for leakage, if the ductwork is, greater than 500 kPa, not that heavy right there, but basically you go through, and because all duct systems, even ones that are maybe eventually were sealed, they may leak at some place. There could be leakage in, leakage out, depends on if it's, pressurized or under negative pressure. But, all that wasted air, in some way wasted, it leads to excess energy consumption. Now we're also looking at, in economizers, in your particular climate, there's no requirements for that point. In others, that is, and so I'm not going to spend so much time on that, But here's one that is interesting right here to kind of look at this. Fan power, and standard 90.1 is included for a number of years a maximum fan power based upon either like the flow rate or just a rated power, for the motor that's all connected into the fan for the certain type size of system. But and at least I know, a lot of people that have done, duct designs, we can always do better. That standard 90.1 is sort of a minimum level that we can do. We can do better than that. And so what the standard 199.1 says, the International Great Construction Code, you do 10% better than that. And it's fairly easy to achieve. When I do these talks on a larger basis, longer time frame, I talk about all it takes to achieve that. Not very bad. It's not very hard to achieve that point. Also, energy recovery, exhaust energy recovery. A minimum of 60% energy recovery effectiveness. That's a little bit higher than the standard 90.1. They still work on the same, threshold tables. Don't want to spend a whole lot of time on this, and unfortunately, I don't have the SI version in terms of the flow rates. So basically, CFM divided by 2 to get liters per second, and a different, criteria in terms of the climate zones, and that's how you look up on and work from there. So if your air handling unit, just one single air handling unit, is greater than this flow rate, you have to do energy recovery for that point. With the exhaust going out and coming out, so air coming in, you have some method to recover the energy. An infantry wheel, a heat exchanger, some way of recovering that point. Now, just kind of getting a little more specifics and the minutia here, I guess, in some ways, but this is becoming more common around the world, but it's still not everywhere. Hotel, motel, guest rooms, so you have the unoccupied mode where the lighting comes off, the HVAC goes off, maybe it disables some of the plugs that are around there, and then it's reset when you come in. Now, one thing that's been added here fairly recently is you have what they call captive key card. Basically, your key to the room, you put that in the slot and that turns on. That can be bypassed. Actually, this is a picture of when I went and checking into a hotel on one of my ASHRAE trips, about 10 years ago, and see that, they had that key sitting there all the time. It's used only for the AC and lights operation only. So basically they bypassed it. So that's why it's coming in. So now we're looking at something with more occupancy sensor type control, or controlled by what other methods have been set up. Also, now we're looking in terms of lighting power. If you may be familiar, the standard 90.1 specifies, the maximum lighting power that's allowed, and you can do it from the whole building area. Take the building type, and this is what your maximum lighting would be, or you can do it space by space, room by room, and work from there. And all we do in this particular standard is slightly adjust those. And they've actually, standard 90.1 and 189 are pretty well converging on this. We're now beginning to reflect the fact that, LED lighting is becoming pretty much the norm, or more of the common, for at least new type of construction. So the lighting power densities will reflect this. And so this one table right here just showing the building area method. There was a corresponding table for the space by space depends on the type of rooms with it. Also, in terms of lighting controls, if you have like a commercial or an industrial storage, a warehouse, you actually have occupancy sensor control to reduce the lighting power from there. And so, I've actually heard stories of people who've been in a warehouse and they can tell when somebody's driving around with a forklift, there, because they can see the lights basically going on and off to track them as they go through the space. That's a way to reduce it. If you have a storage area and nobody's there, you don't need as much lighting as you do with somebody's there. It's actually making sure they select that. And the whole difference now, like we're automated warehouses, say, certain shipping facilities, they might have robots that go through. That's even a better way of going about this. So now we go at the energy performance option. And again, I think I mentioned at the very beginning, it takes it from two different perspectives. First is the energy cost. ASHRAE is used many times, the energy cost as a way to evaluate energy performance. It's been doing that for years for standard 90.1. And so we have a cost target, a performance cost index based upon the type of facility, and you would achieve that. Also, you have a CO2 equivalent, in terms of the emissions that is expected from this facility when it's operating and using energy, should be less than or equal to some baseline that's listed in the tables that's shown on here. So here's energy performance. Kind of looks complicated, but basically it's saying you have a target performance. You can have maybe make adjustments based upon the type of building for the performance part of it. And then you can also adjust for how much is actually might be being produced in terms of on-site renewable energy. So we are basically, it's consuming energy, but it's producing. My house has some solar PV on it right now. That's exactly what I'm doing right now. We're consuming, I'm producing at the same time. Probably it's about right now, since early morning for me, it's probably fairly well balanced out. But in an office building, more than likely that's not going to be the case. But at least you're saving 5%, 10%, or whatever that you might be consuming. So this is our, don't want to spend a whole lot of time in there, but it's based on the different climate zones, realizing that, ASHRAE is writing these standards. The International Green Construction Code, the standard 199.1 is written for somebody that's in Bahrain and Fairbanks, Alaska. There's a big difference in climate associated with that. So what we've looked at in the committee says, how much one is the overall building performance factor, basically adjustments on the energy, in terms of baseline requirement, and also how much could you expect to get renewable from there. Don't want to get into too much of details on there, but describing that. And I have to admit, this particular section, this performance part, has gotten more and more complicated over the years, so it takes time reading that and really digesting of what we're doing. Now, we do give in the standard, CO2 emissions factors, so you can actually convert, what the kilogram per megawatt hour of energy consumed for different source fuel types or just electricity would be. Now, those numbers are based upon an overall nationwide U.S. average. And when they're realizing that standard 189.1 is being written such that it could be used anywhere in the world. So if you have local numbers available, for Bahrain or Lebanon or wherever, you should use those. But we said, here's a number. If you don't know, here's at least something you can use as a starting point to work from that point. And the idea is basically you're going to compute the CO2 emissions for your building that you propose compared to a baseline performance. And if it's less than the baseline, you're good. You've met a minimum criteria standard. And so these are the numbers that will be used to go through and do that computation. If you think about it, if you are achieving the energy efficiency as specified in, say, electricity for your proposed building compared to a baseline, and you're multiplying both those numbers by the same emissions factor, you're going to comply with CO2 as well. So it's the main reason, really, I think, why this was chosen to be done, why we did this in this standard early on, from day one, really, is that it forces the design team and the owner and the project team to do the calculations, at least be aware of what the CO2 emissions footprint would be for this particular building. So it's raising the level of awareness. All right, I want to spend some time now talking about indoor environmental quality and how that works. And there's a number of areas of concern with that. It's not just air quality, so ventilation requirements is part of that, obviously, but also monitoring how much outside air you bring in. And again, that's the third of the three areas we're talking about, including sensors that are ability to monitor and then maybe give a signal to the operations team when something's gone wrong. We also, look at contaminant source control, minimizing the contaminants there, controlling, smoking within a building, the facility. A lot of places around the world are going into, at least in public buildings, are going to, smoke-free. That's good, but that's not everywhere is there yet. Thermal comfort, acoustics. Actually, there was an interesting article, I was reading recently, I think it was ASHRAE Journal, talking about, the acoustics impact on people working like in an office facility or in a school, that noise level influences, their overall performance. They're doing their job. Lighting, this is not just, we're not talking about lighting energy consumption, we're talking about the lighting levels that are provided. Having day lighting open and available to the people, it makes people happier. But also you got to control but the glare that might come from that. And then pressurization and humidity control within spaces. That's maybe not, as depends on what part of the world you're in, but pressurization, is a negative pressure, positive pressure, especially applies in like high-rise buildings. You have the stack effect right there, and you may be bringing in outside air unwillingly through the envelope when you don't really want to do that. You want to control where the outdoor air coming in. And then, actually doing indoor environmental quality surveys of the occupants, particular, within a certain minimum time. I can't remember, I think it's like 1 year, 18 months or something like that after initial occupancy of a building. Survey the people, especially let's say in an office facility. Are they happy with it? Is something not working as well? And then basically, hopefully you fix that. So looking at, some of the mandatory portions of this, just the overall ventilation rate, we have, designed per standard 62.1 for ASHRAE, but also ASHRAE has produced standard 170 that's for healthcare facilities. If you think about that, in a healthcare, a hospital, medical facility, a nursing home, or a long-term care facility, that controlling the ventilation and the balance between pressurization between certain room types, all that, extremely important. And we've seen some of that right here, in the past couple of years with the pandemic, that has really brought that into focus. And then also looking at, this idea of outdoor air monitoring. I mentioned that just a minute or two ago. What it specifies is that on the outdoor air intake for an air handling unit for a building, you have a permanently mounted measurement device that has the ability to detect within plus or minus 10% of the minimum airflow how much is coming in. So basically it just says you install this device. Later on, when we talk about planning for operation, it specifies, okay, here's what you do with this information, and you use that to maybe send the signal if it falls below that. And the plus or minus 10% is actually, it used to be 15%, but we had, several of the manufacturers of these type of devices says, we can do better than that. They all agreed to it. And so we actually changed it to 10%. So that you're even more accurate than what you really might be. Now, other parts in terms of, indoor environmental quality, actually related air quality, is this filtration and air cleaning, minimum MERV rating, it's basically the ability of the filters to work, of how the upstream of cooling coils, actually we've gone through within the pandemic time, and I sense that we're actually going to be having a push towards, MERV 13 levels in terms of filtration, particular in things like, schools and offices or places where people are sometimes maybe more closely gathered together, filtering that out. We also have ideas for ozone cleaning for if you're in a high ozone area, You know, again, I might sense that there might be additions here. This is my own speculation for doing things like ultraviolet, cleaning of equipment or airflow within either air handling units or maybe within the rooms themselves. That's another pandemic thing that we've seen that really is effective when we're going about this. And then just sealing around things like filter frames and access doors to eliminate possible bypass going through the air distribution system. Also looking at in terms of pressurization controls, was talking about idea of when the possibility you have infiltration or maybe exfiltration within this building space when it's not really desired. And so this is basically, I'm summarizing right here, just specifying where we're basically monitoring the pressurization within the space and adjusting it appropriately. So if you have dehumidification capability, and some of the A zones are the ones that are more humid type climates. I happen to live in 3A. You all probably would be in 0 or certainly 1A right there. Basically looking at the maintaining the humidity levels below a certain space. Now, most of the time of the year, that's probably not much of a problem for you in terms of there, but again, my understanding of certain times of the year, that humidity is a potential issue in kind of dealing with it. So this is something, idea is not to let the humidity levels go too high in a humid type zone. And then looking at, before a space is occupied, a guest room, in a motel, pre-occupancy purging. So basically looking at, that room could have maybe been sitting unoccupied for a couple of days, and then now a guest comes in and checks in, and maybe the motel or hotel operator knows that somebody is going to be checking in to room 727, and they have the ability, or they have an automatic purge, basically extra ventilation to kind of clean out the air before the guests arrives right there. Same thing for zones that are not continuing occupied. Let's imagine, say, an office space. So say at night when people go away, the system goes in, either shuts down or at least it goes into a cycling mode. But with designed for a period 1 hour before the expected occupancy starts, before people get there, you turn the ventilation system on and basically, again, purge out some of the air, get it fresher for with people coming in. Now, there's other areas that are included that we don't have time to get in here to today. Thermal control and acoustic control. Oops, I put the acoustic control twice. And then lighting at that point. Again, I don't have a lot of aspects of time to go into this. Moisture control is another one. That in terms of through the building envelope, that maybe not quite as important. Again, for people I'm talking here today, but there are some parts of the world that is a big deal in going about this. The prescriptive option. Now, those are all a mandatory part of looking at the indoor environmental quality. The prescriptive option, there are a few items that still covers right there. One of them is in daylighting and shading and low emitting materials. And then there's our performance options to go through and do it. So that daylighting option, in terms of minimum out there, well, there are software tools that allow you to do daylight simulation modeling. Down here in the lower left corner is an example of one. Maybe in an office space that you have, the sunlight coming in. Notice that a certain part near the windows right there is pretty high. It's a glare type situation. If you had a desk that was sitting right there, that may not be as comfortable for the person. You may have, hard to see a computer screen, something there that and dealing with this. Also, in terms of the materials that are installed within the space, the materials emissions, you get paints or carpeting or furniture materials that maybe are emitting off-gassing volatile organic compounds that are not as good for the people there. You want to minimize that what's coming in. And then lighting levels as well. So there's where the daylight simulation models, computer models should use hourly simulation, language, go through and do it, make sure minimum amount of daylight levels in terms of how far it goes back into space, but also minimizing the direct sun on, let's say, an office workspace. And that's where you kind of show what would be and work from that point. the materials, there's actually a procedure that was developed in California for going through and adding up all the VOCs or volatile organic compound, the concentrations from each of the materials that are included in the space. You add them all up and make sure that the total does not exceed a value, of what that would be that's considered being, not harmful, but at least, negative in terms of the overall occupants. All right, we just got a couple more sections to talk about here. The buildings impact basically the materials. Look at this. We won't spend a lot of time on this right here, but there are certain aspects of this are considered mandatory. Basically, during the construction process, construction waste management, making sure that, you recycle materials as much as possible. Looking at, if you have still using fluorescent lamps, specifying the low mercury lamps right at that point, having a storage spaces for recyclable materials during the operation of the building. And then, that's all mandatory. The prescriptive part is, again, looking at using reduced impact materials, incorporating maybe recycled materials into some portions of that. Or, and also, if you can, regionally based, regionally specified materials. Now, for a place like Bahrain, that may not be as easy to achieve, but looking at working for that point is trying to improve the types of materials that are specified. And then, performance option, just alternate to the prescriptive, is doing what we call life cycle assessment. There are software tools that can go through and do the calculating, say, the carbon footprint or the embodied energy within a particular building. Now we look at the last and final section right here, construction planning for operation. So similar to what, say, like other green building programs, they go through and describe how you do the construction process. But then specifically within the International Green Construction Code and Standard 189.1, it specifies, when or mandates that you do commissioning on buildings above a certain footprint or floor area right there. There's also look at, indoor air quality during construction, maintaining that, sealing off ductwork when the construction is going on, so you don't get, dust and other materials inside that, and also maybe the construction vehicles and the idling of those vehicles when they're increasing emissions into the space when it's not really being used. The one thing that was the big contribution, I would say, of this particular standard in terms of overall green buildings, around the world, high performance buildings, is that, it requires the preparation of a building operation plan in some key areas, like within the sites and within water use and energy efficiency and indoor environmental quality. In particular, I'll focus on the water use, energy, and IEQ. We had the specification that you've included, these meters. Meters are monitoring the amount of water used in say, a cooling tower. Meters are monitoring the amount of energy that's used in, say, your lighting system, or the meters that are monitoring the outdoor air coming in the air handling units. Those are all those three bullets right there. So what this says is that now the building project team and the owner, working with the operations, prepare a plan for, all right, here's how we're going to use that information. Let's say, just picking one example, if the outdoor air intake coming into this air handling unit falls below the minimum of what we expect for that particular air handling unit and the zones that it serves, something's gone wrong. A damper stuck or whatever right there. So it sends a signal to the operations team, and this plan for operations says, here's how we're going to respond. We are going to do an immediate check. We're going to shut that, whatever. This is what we're going to do. The standard does not specify what you do. It just specifies you make a plan and you follow that and going forward. And a few other plans for operation, including in terms of overall building maintenance and looking at the service life of the building. Maybe there's certain parts of the materials that the manufacturers recommend after 20 or 25 years, you need to do some kind of check on this and maintain it so that it does last as long as you would expect at that point. It's fairly open-ended, but the idea is getting the building owner and the operations team to work with the designer to come up with, all right, here's how we should operate this building for the next 10, 20, 30 years. Now, it's pretty much concluded most of the technical part. I just want to go through and then, remind you that ASHRAE has a number of Learning Institute courses that are related to high performance building. There's a basic high performance building design, there's an advanced one, there's a future trends course, and then there's actually one to, overall building demand response and the smart grid from there. So with that, I will wrap it up right here. And if you have any kind of comments or concerns, questions, advice, there's my email address down the bottom. Happy to take those, anything from there. I have not been able, since I was in full screen mode, to go through and look at if there was any questions in the chats or anything like that. Did anybody see something from there? Okay. Yeah, so that was just a question from, to put into everybody else. Don't see anything. Do you and the attending? So do you want me to stop sharing right now? And we go back to normal, or maybe I'll have, if you want, these are some questions that I had put together, and maybe you just kind of go through it and look at some of yourself and think of, your takeaways from this right here. If you just describe, how the difference between, say, the standard 189.1 would be, say, a rating system. What were the differences I talk about? How much we could go through and do, how much energy savings have we come over the last 20 years in terms of the standards? About the percentage of lower fan energy. You remember that, what that number might be? These are some things just kind of prompting some thoughts. These are not necessarily, these are my questions to you, or to at least be thinking about them as the evening goes forward from here. All right, I think if it's okay with you, I will stop sharing. Now we go back to your regular screen. It looks like you've got the Bahrain chapter points. And I thank everybody for inviting me. I add one more country to my list in terms of talking virtual. Unfortunately, I was actually at one time, I remember, maybe 10, 12 years ago, we were trying to work out an actual visit to the Bahrain for an ASHRAE, and it just didn't work out. Hopefully, we're getting closer to having more.
Yes, Dr. Tom, it was 2011, and I was communicating with you.
Oh, okay, yeah. And that's, things happen. I don't remember the deal with what happened there, but it just didn't work out. But that's okay. We got through these. And again, I'm beginning to sense it's not this year, but maybe started later on in this year. 2022 and going forward, we'll have more face-to-face type meetings going about this. The only ones I've done face-to-face in the last 2 years have been my own local chapter in Atlanta. I took some students over there in November and I actually did a DL talk for that. But we're not quite there yet, but we're getting close. I'm a glasses half full person, so I think we're getting on the backside of this. The world was learning how to live with that. But it looks like we had a fair number of attendees. That's really good to see that. You have almost.
Thank you, Dr.
Yeah, almost your whole membership.
That is true. Yeah, thank you. Thank you for a very informative presentation. That was a lot of information you covered in this presentation, and it gave a very nice bird's eye view of ASHRAE standard 189.1. We do have a couple of questions here. I'll take those questions. The first question is from Mr. Said Haq, and his question is, what is the criteria set for humidity control in residential towers?
Okay.
High humidity.
Yeah. So one thing I didn't really point out in too much detail in here is that the 189 standard would apply to, the only part of residential that applies to would be high-rise residential. It does not apply to, single family or multiple family but smaller facilities at that point. But in terms of the high-rise residential, it's difficult to, I mean, you can't really control much how the occupancy is in that particular space right there. And so the humidity control criteria that's listed in the standard really only applies to a commercial operation right there. In the residential part, it's extremely difficult because every, people operate them differently. You can design a system that would be effectively maintain the humidity control in the space, but now you're at the mercy of how the people operate it, really.
The second question is from Mr. Hasif Ali. His question is, what about the sound nuisance in green building?
The what use? I'm sorry?
The sound nuisance. How does
You're talking about the acoustics?
The acoustics, yes.
Yeah,
The acoustics.
yeah. So, and that's part I went through fairly quick, but the basis of what the standard does is there's a rating that's like the sound transmission quality criteria that you can rate the structure, combine all the materials put together. It focuses on both external sound coming in and also internal between different spaces. The external would be things like if you're located near a busy highway or near an airport or something like that, where you have sound problems. But internally, it would be in like between different rooms in a hotel. I mean, you want to have the sound transmission rating between the walls, between the different spaces, so that you can't hear your neighbor's telephone call at 2 o'clock in the morning or something like that. Also, in some cases where you might have, let's say, for example, like a school, and you have a school room that might be located right next to a mechanical room. You want to minimize that because you would have sound, acoustic problems there, or if it's near located a lunchroom or something where you have a lot of people running around right there. So that it focuses on key areas where we anticipated that there would be a sound or an acoustic problem. And the way it addresses that is the rating of the sound transmission between the various walls, either external wall or an internal wall.
Okay. The next question is from Safiq. His question is, does 189 take into account future climate scenarios like rising temperatures?
Yeah, that's an interesting portion of this, and we were beginning to talk about that within the committee of how to address that, and how do you go about this, and we have it does not yet, but that is something that is being talked about, but then you kind of think about, you have to specify the exact language that. So what do you plan for? How long do you plan for? 20 years in the future, 30 years, to what level? And that might make a difference also what part of the globe we're at in terms of what the temperature capability would be. But recognizing that this really fits into part of ASHRAE's strategic plan, and I think in terms of what we call resilience. You're designing at least the capability such that that 20, 30 years from now, the design cooling point is going to be this, a little bit higher at that point. So do my systems have the capability of handling that? Or if not, what are we going to have to do in 10 or 20 years from now such that they do? You don't want to oversize so much now and operate lower efficiency such as you're planning for 20 years later. So that's, it's I'm not making excuses, but it's really complicated. We recognize that, we're beginning to talk about that, but right now the standard does not specifically says you design for the design temperature expected 20 years from now. It doesn't do that yet.
Okay. The next question is from Mr. Mohammed. The question is, what is the size threshold for applying 189.1 to the projects?
The size threshold there is no size threshold per se. It applies to all buildings, new buildings. There are thresholds for things like commissioning. And if I remember right, it's like 500 square meters or less. You do not really have to do full level commissioning. It used to be 1,000 square meters, and there's been talk about what that size criteria would be. So basically, small spaces right there. But there is no minimum or size threshold above which everybody has to comply, and you're below that, it doesn't apply. There is no cutoff for that.
Okay. I think we are done with the questions. Only one question that I have from my side is, if we comply to this ASHRAE 189.1, whenever it is mandatory, how many lead points would you automatically get?
Now there's no direct correspondence. We've done over the years. I've looked at for one, it depends on what type of building we're talking about. So an office building versus a school. It depends a little bit on your climate. But in general, the people on the committee, they've been working on this for a while. People have gone off independently and they've done, say maybe one of their projects they're working on, and they apply everything in 189, and then if they compare it to the lead, typically it comes out as somewhere in the high lead silver range, but there is no guarantee. Now there's been talks between ASHRAE and the Green Building Council on can we make one possibility has been discussed is maybe make the prerequisites for lead. If you meet say 189.1, you automatically met all the prerequisites, and also maybe you get certain minimum of some of these credit points. But that's not there yet. So I'm just answering your question. In general, it would be maybe a lead silver, high lead silver. It might even be more than that. It depends on the type of building, climate, that type of thing.
Okay, I think that is it.
But I use that. I use that as at least an example, so people can have a gut feel. So this 189.1 standard, if you apply it, it kind of puts you in that high lead silver range, plus or minus. That's one way to look at it.
Okay. With that, I will request Mr. Dacey to take over for the vote of thanks, please.
Thank you, Amol, and thank you, Dr. Lawrence, for the nice time we had with you listening to 189. In fact, Byron is currently it is implementing Green Building Code of its own, and many of the points which you have raised corresponds to the Byron Green Building Code also. So it was a nice coincidence, and it's a nice reference for us to take back and to work and implement it. And I would also,
I think that's the purpose of what ASHRAE has prepared this, realizing that it hard, I'm sorry to interrupt you, but it's hard to adopt this directly, but here is it out there, and here are ideas that you can maybe modify.
yeah, so that's the right thing. So even it corresponds to lead everything together. So hopefully everybody will be aware of the energy efficiency measures and implementing it to the best of the possible thing. And definitely we would like to have a in-person face-to-face seminar whenever it's possible. Currently we are in the green level, so we are kind of coming out of COVID. So hopefully in the next 2-3 months we should be able to arrange something in a face-to-face seminar also. And I once again thank you, Dr. Lawrence, for the time you are taking to be with us and share your knowledge with us. We had a good participation today, and I would like to thank all the participants also who joined in and took advantage of the webinar. Vinod Amol and Shahbaz has worked hard to put this webinar together, And I would also extend my appreciation to them for this and for conducting a successful webinar. And last but not the least, RAIN and BTA was always our support, and they have sponsored this webinar also. And it has been a great support from them. And I would like to thank them for the support which they have extended. And as you all know, there's a team building or the lead reporting hours which is available here. So the details are as shown on the screen, so everybody can take advantage of that and have 1 hour of lead reporting there. I would also thank Pankaj and Adil for their support. And with that, I think we can conclude this webinar. Thank you, Dr. Lawrence. Hope to see you in person sometime.
Yeah. Bye, everybody.
Thank you, Doctor. Thank you, Doctor, very much.
Thank you.
Thank you.
Thank you, Doctor.
Have a nice day.
Bye.